DROPBOX. That is not what we're going for. That's not what let me, sweet. Hey. You know, you'd think I'd be good at this by now, but apparently not. Technical difficulties. Sorry, just a moment. So while I am dealing with my technical difficulties, I'm just going to make some terrible jokes. So I had a friend, he quit his job recently as a programmer. The reason for that is he didn't get a raise. Yes, I make terrible jokes. That's what I do on my podcast. It's literally, there's a section called Matthew's Jokes and we read them. Yeah, I'm just ridiculous. Anyway, hi everyone. So my talk today is called TypeScript, Seeing Past the Hype. I realize that sounds like I'm about to go on an indictment of TypeScript, but that is actually very, very far from the case. I love TypeScript, and at the end of this, I hope you will too. So, my name is Matthew Gerstman. I am a software engineer at DROPBOX. I live and work in New York City, which I love, but I also love visiting Chicago. In fact, I have family in Chicago. My cousin Adam is in the audience, and I would really like to make him uncomfortable. So could everyone just say hi to Adam for me?
Hi, Adam.
He's right there in the third row, over there. Anyway, I've now made him uncomfortable. His wife, who is my cousin by blood, will be very happy I did that. I said my podcast, The Console Log. You can find me on Twitter. I tweet way too much. These slides are available at typescript.matthewgerstman.com. And let's kind of get started. So at the beginning of this year, I noticed a lot of hype around TypeScript on Twitter. Just like a lot of hype. So much. Just everyone was like, I need to learn TypeScript. I really appreciated Jane Wong chiming in and just being like, why does everyone want to learn this? And it wasn't just Twitter, right? It was like Medium and Quora and Reddit. And Sean Wang was like, everything I write in 2019 will be in TypeScript. But this actually isn't a 2019 thing. In fact, this graph dates back to 2014. TypeScript is older than that. And you can see the interest in TypeScript has gone steadily up and to the right. And a lot of the time we like to compare TypeScript to CoffeeScript, which was, who here worked in CoffeeScript at some point? Yeah. Everyone hates CoffeeScript these days. So CoffeeScript was great for its time. It evolved into what became ES6, but it wasn't syntactically similar to JavaScript and it had a lot of issues. But the thing is, CoffeeScript died after about 3 years, whereas TypeScript is 7 now. So we really can't meaningfully compare them, which that's the tweet I got that quote from. So today we're gonna get past the hype because when we're talking about tools, I think we do way too much of this. We get way too excited about the new shiny thing, but really, we should be sitting at the whiteboard with bubblegum tape and figuring this out. So we're gonna go into some of the ugly parts, and then we're gonna talk about why I think it's worth it anyway. But first, let's take 10 steps back and just go with what is a type. So a type is an attribute of data that tells the computer how the programmer intends to use it. And you're probably already familiar with some basic types in JavaScript. So we have booleans, true or false. We have numbers, so 1, 42, decimal numbers, etc. We have strings, which are just text. We have arrays and objects, which hopefully I don't need to go into more detail about. We also have a bunch of falsy types, right? We have null and undefined, which are slightly different from each other. And then never and void, which are in TypeScript and confusing, and I'm not even gonna bother addressing. I'm just gonna say they exist. Types can also be derived from other types. So we can create interfaces that say like, hey, this object is of this shape, this is what we expect, or we can combine them and do nifty things. TypeScript also, this is the last thing you need to know, gives us a special type called any. And this is effectively an escape hatch. This says, hey TypeScript, please trust me, I know what I'm doing, I either can't express this in your type system, or I'm using some third-party module that I can't type, or just something about it. So what exactly is TypeScript then? Well, TypeScript is a strict superset of JavaScript, and it looks like this. In fact, the only thing that makes this different from vanilla JavaScript are these type annotations right here. So we have this function that takes a string, which is an argument, and you can see I've annotated the argument as string, so I've told the function I only want strings. And if I go and pass it a string, it's gonna work just fine. If I pass it something else, it's gonna complain right in my editor. TypeScript is also smart, like really smart. So I have all these functions here that are just DOM functions, and I'm using getElements by tag name, which allows me to query on an anchor or a div or a paragraph tag. And depending on what string I pass this function, TypeScript is going to know that these are different types because anchor elements have hrefs and paragraph tags don't. It also makes big refactors really easy, which I'm going to show you now. So we are going to mirror my display and switch right over. So first of all, I am a huge Harry Potter fan. Who here is a Slytherin? Anyone? You are my favorite. Is anyone else a Harry Potter fan? Cool, okay, so I have this component, it's called Slytherin. They just have name and age. I also have some famous Slytherins that might be on the other side of my code base, and those are Taylor Swift, who I love and adore. There is Lin-Manuel Miranda, and there is Merlin, who was also a Slytherin. And let's say we want to add a property to this component, right? So at Hogwarts you can earn house points, so we're going to add some house points, and we type points, and if I can get the syntax right, the first thing you see is this really nice error message that says, cannot find named points. And it's like, well, that's useful, that's basically what we expect. So let's add this to our function call, to our function signature, so we're destructuring it. Now there's a new red line. Property points does not exist on type props with children Slytherin props. So it's a little, there's a little thing there, like what's props with children, but whatever. Okay, we know we need to add this to Slytherin props, which is right here. So this is the really special bit. So you see, I just typed a P, and I'll finish typing the points. But the second I typed that first character, my editor lit up. In fact, if I had other files on the sidebar, those files would have lit up in red, or if it were a sufficiently large code base, I would have run type check, and I would have seen this exact error. Property points is missing in type, name, age, because it's not in there. So let's go give everyone a bunch of points. So Taylor Swift makes a fortune and is going to make a fortune on her next album. Lin-Manuel Miranda is literally printing money from Hamilton, so let's just keep adding zeros. And Merlin is dead, so he can have 5 points. Now, TypeScript is also very incremental, or at least it claims to be. This is one of the selling points. So let's say we have a muggle, right? And we're going to name our muggle Vernon Dursley, if I can type his name right. And this is really nice. So I type muggle and I type dot, and I immediately get dot completion because TypeScript and VS Code, which is very tightly integrated into it, knows what the functions are on a muggle. So now I have const yelling muggle because Vernon Dursley yells a lot if you've read the books. And let's say I want to call something different now. Let's say I want to call slice. I want to get a portion of it, but I'm going to make a typo. I'm going to type splice, which is a function on arrays but not strings. And I'm going to find out right in my editor, cool, property splice does not exist on type string. Did you mean slice? That's really nice. So what about external libraries though, right? So we use Lodash, lots of people use Lodash, so let's import Lodash from Lodash. I'm not be able to type, I am not as skilled as Michael Jackson at the live coding. So anyway, cool, I get dot completion on all of these Lodash functions. Whoa, let me start typing filter, because I want to use that. And I type filter, and it tells me the type is collection of string, which I think I can filter over anything, so let's make it an array. Whoa, I type array, and it immediately knows that array could be an array of anything. So let's put some numbers in here. 1, 5, meaning of the universe, 100, amount of money Taylor Swift has. And when I go to type my type guard, my iterator here, I have my value, and it knows that value is a number. So we're only going to return values greater than 10, and if I hover over this, it knows that it's a number. And if I try to type value dot slice or something, it would know that it's not on a number, so we have that. How does this work? Let's take a peek at these types for a second. Whoa, this is not a thing that I understand, or at least certainly not a thing I expect anyone to understand after just looking at TypeScript. What are these brackets? What are these pipes? What with question marks and so many things and just references to other things? I don't know, let's click on list iterate custom. Whoa. No, you don't need to know this. Let's do something simpler now. Let's type a wizard. So we're gonna make an object, sweet, and this is totally valid JavaScript. Our wizard's name is Harry Potter. Well, this is strange. Property name does not exist on type object, but this is totally valid JavaScript. This is just a thing that you might write. Okay, so let's type our wizard. So we type, and we type wizard, and we give it a name property, string, and then we go and annotate our object. And now it's complaining up here that it's missing the name, which we could do in the function signature or the original declaration of the object, but maybe we don't want to. Maybe that's just not how we want to write code. And that's where we kind of get to the friction that TypeScript introduces. TypeScript is going to get in your way for the first few months. Like, that is just the fact that you're going to live with. How many of you use one of these two functions, lodash.get or lodash.set? Are you familiar with the string version of this, where you can type like a string and be like, I want like x.y.z, and it'll just sufficiently drill down for you? There is no way to type that. TypeScript just cannot handle that. So you have to hope that nullish coalescing is going to get into JavaScript sooner rather than later. Testing is also kind of ugly. So tests are going to require very well mocked data or just a lot of any's. So you probably need to store big mocks of your data, or TypeScript is just going to scream at you a lot. A lot of this comes down to the fact that advanced JavaScript translates to advanced TypeScript. I'm going to talk about one of Michael Jackson's favorite patterns, higher order components. Yeah, I think this man single-handedly killed this pattern, which may be good, may be bad, but we're going to talk about how hard this is to type. So if you're not, who's familiar with a higher order component? Just so I can, cool. Everyone's mostly, but we'll go over it. So we have an HOC, which is wrapping another component. It's a function that takes a component, and it's going to inject some props. Let's say an HOC might give a screen size prop, so we can do responsive stuff in JavaScript. And we want that screen size prop to come in to our wrapped component, but we want our regular props to come in from the outside. Okay, so we have to convince TypeScript that that's how these props are going to fill in. But what if we want to force a screen size, right? Or just test in isolation? Well, we also have to convince TypeScript that it's going to be able to receive the regular props and the HOC prop on its own. And this is really hard to type. You need to know about generics, which are a special thing where a function can infer the type when it's being called. You need to know about intersections, which involve combining types. And you need to know about discriminated unions, which allow you to do an OR on types. I don't expect any of you to know that. Most of you have probably not worked with TypeScript before, or, yeah. By the way, if you are curious, it took me 2 weeks to learn how to do that in 2017 because not a lot of people were using TypeScript back then. Now there is a ton of documentation. If you want a blog post on how to type an HOC, go for it. The other thing you need to know is that TypeScript isn't sound. So it allows certain operations that we can't guarantee the safety of at compile time. And some of this comes just from the complexity of JavaScript, but also this comes from the fact that anyone can put an any anywhere in your code base, which immediately breaks type safety. So remember how I said that types, like an any just means, hey TypeScript, please trust me? Well, it's a little more like this. One more loop. Cool. Something that's really hard to type properly is React context. So is everyone familiar with React context? Cool. So we have this provider and consumer, and we have this kind of magic data flow in the middle that React takes care of. And there's really no way to guarantee that the magic data flow is properly typed. So what we can do is we can pin a type to the provider and pin a type to the consumer and trust our engineers to do the right thing. But there's no guarantee, at least at the TypeScript layer, that React is doing the correct thing right now. And that's frustrating. That gets even worse with React Redux, right? Because Redux is heavily implemented with context. Thunks are also very hard to type, especially dynamically. So when you want to bind an action creator and have TypeScript automatically figure out what's going to get returned or what's going to happen, it's just not going to do a very good job. You end up just telling TypeScript what you mean and saying this is going to be the case. Dispatch is even harder, especially with middleware, because this thing is changing at runtime. And if you might have a switch on what's getting injected at runtime, then help you. A lot of this comes from the fact that TypeScript is a strict superset of JavaScript. We're bolting on types to a totally untyped language that can do lots of things. So while this function is stupid, it is completely valid JavaScript. So it takes an argument, and if that argument is Harry, it returns a number, 7. If that argument is Ron, it returns undefined, which is a different type. If it takes Hermione, it returns an object, another type, and anything else, it just returns wizards, because why not? But this is valid JavaScript. This will work in our browser just fine. We could theoretically use a similar function. In fact, you probably do use functions that return completely different types depending on what's passed to them. This is where I cut and say all of this is still worth it. The first thing we have to acknowledge is that TypeScript is just another tool. It is not a silver bullet. It is not going to solve all of your problems. I am not here to tell you that TypeScript will make your code base perfect. I'm here to tell you that TypeScript is going to eliminate an entire class of bugs. And that's really the value in adding TypeScript to your repo. So how many of you have seen this bug before? Undefined is not an object, right? Like if I go and type a variable and make a typo, it's just gonna catch that very quickly. It's gonna catch that either in my editor if I'm in the right file, or it's gonna catch that in my terminal when I'm running type check. How about this one? Variable is not a function. You already saw this when I was testing. You saw this with splice, and not only was TypeScript smart enough to catch it, it also knew what I actually meant, which was super cool. And then changing interfaces, that's a huge one. Like I added a prop to that Slytherin component, and all the way on the other side of my code base, many, many modules away, I knew that something was broken because I didn't have this required prop because the interface changed. And those are the kind of things that are hard to guarantee in a code base. This gets even harder when you work at a company like DROPBOX and you're dealing with our scale. So we have hundreds of engineers working on the same code base. We have millions of lines of TypeScript, some hundreds numbers of features, and then offices in 4 time zones because we want to make this even more challenging. 3 time zones, actually, 4 offices. TypeScript is a very core part of our front-end workflow. One of my favorite examples of how TypeScript helps us is when we upgrade libraries. So all TypeScript types are, for almost any library now, because the community is so strong, are available on this repo called definitely typed on GitHub. It's huge. And let's say React or Redux or Lodash or just anything you might use, it's probably going to have these third-party type declarations on definitely typed. And those are iterated on independently from the actual library, but they're pinned to the library version, so they're valid. So when we go to upgrade a library on those millions of lines of code, the first thing we do is we just swap out the types without changing any of the runtime code. And that way we can just see, we can run type check, and we're gonna catch the vast majority of the things that break. We have, when we go and upgrade a library, we usually have single-digit number of bugs, and it's usually something very stupid that we could have caught, or that we wrote down and then we don't catch the next time, because TypeScript just catches these things for us. Some examples of the types of things it catches, so like deprecated features, if a function goes away, or a lifecycle method changes, or the interface for a method changes, all those things just get caught. And then on top of that, because these types are in their own repo and being iterated on by people who care about TypeScript, they're often just getting better. So sometimes we just upgrade our types, not even the library, and we catch new bugs that we didn't know about that when you're dealing with millions and millions of users, you're likely to start running into. To be totally honest, at our scale, I don't know how I would upgrade a library without TypeScript. I don't know how I would take millions of lines of code and get them to use React without having some really good checks there. TypeScript also allows us to place constraints on our engineers. And you might be thinking, why would I want to place constraints on my engineers? I want all the freedom to do whatever I want. Well, if you think about it, the simplest way to build a bridge across Lake Michigan would just be to dump a bunch of concrete across Lake Michigan. That is the simplest approach. And you could do that, but it would be a very bad idea, and you would mess with a lot of things. The smarter way would be to actually hire an architect and use triangles and all the other things that I don't know because I just write code. But there's a better way to build a bridge than dumping concrete in a lake. So one of the problems we had was we wanted to test React 16.8 in production, right? We wanted to go from 16.7 to 16.8. And or if you don't know, that's the one with hooks. And developers will start using hooks as soon as we let them. In fact, here is a simulation of our engineers. Our poor web platform team is looking at them, and they're just like, please help me. We can't give these to you just yet. We need to test 16.8 in production and make sure that we can roll back if there is a bug that we don't know was introduced in that minor version, and that happens. So the solution to this is we roll out 16.8 behind a feature gate, and we slowly test against real users 16.7 and 16.8, but we keep the 16.7 types, so our engineers can't start playing with hooks. And the reason for that is if an engineer adds hooks and we have to roll back, we've now broken the new code that relies on the new thing, but we don't have that guarantee yet. So once we're confident that 16.8 is going to work, and this process takes like a week. Like really, it's just like test against everyone and roll it out slowly. When we're confident it works, we add the types, and then everyone gets to play with hooks, and that's great. Another super cool thing we do is we restrict Lodash usage. So we have a custom Lodash bundle for perf reasons, and we don't want people using functions like chain, which require all of Lodash, or maybe we want them to start using ES6 map instead of Lodash map because Lodash was written years and years ago, and now we have most of these features baked into the language, and we eventually want to kill it. So I literally refer to this as a firewall in my head. It's a typings file that says, these are the functions that we're going to pretend to actually exist in Lodash, and that way engineers just can't even use a function that we don't want them to. And if there's something missing, we add it, and it's low overhead, but that very rarely happens because most of them are there. We have a very long blog post about how we did that migration. This is actually on the underscore to Lodash migration, but it's kind of cool. Now, you're probably wondering, what about small teams, right? I've been talking about a giant company, or at least medium-sized company. And your team is probably 10 engineers, or 5 engineers, or 3, or maybe it's just you working on your project right now. And a lot of people are going to claim that TypeScript gives you free documentation. And you saw me accidentally cut to this slide, so you know I am not going to claim that TypeScript gives you free documentation. A lot of people are also going to claim that it gives you free tests, and you need to keep writing tests. What TypeScript does give you across the stack is contract validation, which is very cool, from the back end all the way to your component library. So what is a contract? A contract is a precise and verifiable interface for software components. The most important part of this is that it's verifiable, that we can test this contract. So for example, for your API, you could be using GraphQL or Swagger. At DROPBOX, we use a thing called Stone, and we auto-generate our backend types into TypeScript. So if a Python engineer or a Go engineer goes and changes how an API is laid out, we're going to know immediately before they merge the code that they're going to break something on the front end. Similarly, on the exact opposite end of the spectrum, if our design systems team goes and upgrades our component library, we're going to know everywhere they're using that component library if something's going to break. And individual teams, which are mostly on the 5 to 10 person size, they can put these contracts within their code. Sure, the contracts with Redux aren't perfect, like I've already described, but they can add a lot of kind of guarantees in there to make their code more safe. And I want to show you some actual code of how this works. So I have this type on the back end. It's a user. And a user has a user ID, which is a number, and it has a name, which is a string. And this function might be auto-generated, it might be something we write on our own, but somehow we have generated and guaranteed the fact that the backend and the front end are in sync. So this function returns a promise of array user, and we have propagated this type into our front end from our backend. We then might have a Redux action, which has a payload of type user. So we are pushing this type from our Python layer down into our front end layer. And when we go and dispatch the action, it's going to return this type, which includes the user. Similarly, our store itself, our actual Redux store, will again include this type. So this type is just propagating and making its way through the code base, and as a result of that, we're maintaining a contract. So when we go and we do kind of a shift on the contract, when we go from a user or the shape of our Redux store to a string for the actual component, we know that it's going to be a string and it's going to be safe, and then our component just renders out and it gets a string and it's not such a big deal. And all of that is possible because this user type has been propagated all the way from the very top of our bottom of our stack, top of our stack, however you want to look at it, all the way to this contract shift where we say, okay, now we're looking at a string which happens to be part of user. If that name changes or moves to a different object, we know this is the function to update. And I like to argue that TypeScript increases in value over time. So this is just a very conservative graph of how many lines of code a small team could produce. This is saying 20,000 lines of code in 3 years. After making it, I realized you could easily produce 200,000 lines of code in 3 years by yourself if you're just chugging away. But a team of 5 or 10 could certainly chug out many thousands of lines of code. Are you going to remember how every single piece interacts with every other piece? What if you have a core form library that you're using on your login page that you wrote on day one because login is the first thing you write, and then you go and you change something about it, and it's going to break login, or it's going to break the flow, or it's just going to look weird to users, you're probably not going to remember that. And maybe you wrote tests, and that's great, and you should be writing tests, but unlike tests, TypeScript gets in your way while you're typing. So for your unit tests and your integration tests, you have to manually write them, you have to think of all your cases, and you have to run them after the fact, and it's a longer feedback loop. With TypeScript, you're getting that feedback loop right in your editor or in the code or in the type check. And I want to come back to my previous point. TypeScript is not a silver bullet, right? You still need to write these tests. Like, we're not going to catch end-to-end things. That's not going to happen. You still need to review your code. You need to be doing code review. You need to be working with your team. And you still need to lay out architecture and think about it. Like, this is not going to solve all these problems. This is one type of screwdriver. This is not every tool. But I kind of argue that the metric for success on a code base is how few things you need to keep in your head at a time, because that allows you to develop in isolation and not really worry about breaking other things when you're touching one particular section or module. TypeScript allows you to forget about other parts of your code base. And really the entire cost of it is learning it in the first place, which will take time and will be a pain, but that's the cost, which isn't so expensive. So thank you so much. I have a bunch of references. You can find my slides at typescript.matthewgerstman.com. I hope you enjoyed this.